Hi, this is a quick video on definitions of vectors and scalars. Let's get right into it. Vectors and scalars are two different types of quantities that we're going to be seeing in physics and also other sciences, but in particular physics. A vector is a particular type of quantity that has both a magnitude and a direction. And by magnitude, we just mean the size of the measurement. It has a number and a unit. Or maybe it doesn't even have a unit, but there's some number, it has a size, even if that size is 0. By direction, we mean a spatial direction. A vector can point north, east, south, west, up, down, at an angle of 45 degrees, at an angle of 13 degrees above the horizontal. But it's only a vector if it has a single direction that it points in space. If you cannot point your finger in the direction that that vector points, it is not a true vector. We represent vectors with arrows. And we can see a few arrows down here. Here we have a vector 140 meters per second to the northeast, so we draw a northeast pointing arrow. Now for any vector arrow, we have two important things. The length of the arrow is proportional to the magnitude of the vector. And the direction of the arrow is the direction of the vector. Seems kind of obvious. So I actually have three different vectors that are using the same scale here. 140 meters per second northeast here. This middle vector is 60 meters per second east. Different direction, so different direction arrow. And since it's a little less than half the magnitude, 60 is less than half of 140, the size of the vector is a little bit less than half of the size of this northeast pointing vector. And here we have an 80 meter per second vector pointing straight down. That straight down is going to represent 80 meters per second south. So length is the magnitude of the vector and direction is the direction. One other important thing to note, a vector, the only thing that matters about a vector is the magnitude and direction. So you can translate or slide a vector anywhere, and that doesn't change the vector itself. It's still the same vector, it's just starting at a different point. That's going to be important when you're doing vector addition, vector subtraction, and vector operations. So vector is this new quantity. The other type of quantity is the traditional quantity that you're used to. It's called a scalar, S-C-A-L-A-R. And scalars have only magnitude. They do not point in a particular direction. So you can't point your finger in the direction that the scalar is pointing. And here are a few examples of different vectors and scalars. Speed is a scalar. It's how fast you're going, but not the direction. Velocity is a vector. It's how fast you're going and the direction. Distance is a scalar. 10 kilometers tells you how the distance that you traveled, the length of the path, but it doesn't have a direction. Displacement is a vector, 2 blocks to the north. How far you've gone and in what direction. Some other scalars are going to be temperature, mass, volume, energy, and power. This is not exhaustive, there are more scalars. But they don't point in a particular direction, they're just quantities with an amount. Some other vectors might include acceleration, force. When you push on someone, you push them in a particular direction, and momentum. Momentum is going to point in a particular direction. So, in summary, scalars have only magnitude. Vectors have magnitude and direction. That's that. Hope that was helpful. Bye.